Hello, everybody, and welcome to the ArcGIS Analytics for IoT webinar. My name is Adam Pittman. I am a team lead for our natural resources sector, and I am joined by Suzanne Foss, who's our product manager for ArcGIS Analytics for IoT, and I am joined by Matt Ballard, who is a solution engineer on our natural resources team. Today, we're going to cover a few topics in analytics for IoT. If we could advance to the next slide. Digital transformation is a buzzword that we've heard for several years now across our industry. It's something that we're all working towards right now, and we're doing that for reasons to make better, more informed business decisions. So we're trying to take what happens in the field and actually replicate that in a digital way so that we can increase our performance and operations. Before we get started in talking about some of our customer stories, I would like to let you know that today's webcast is being recorded. We will share this recording with everyone as soon as the event is over. We are also going to take questions. So all of you should have in your chat dialog on the GoToWebinar control panel, you should be able to input questions. So we'll be monitoring those questions throughout the webinar today. And we're going to save plenty of time at the end to answer your questions as best we can. So in order to get started in analytics for IoT and what this product is and why Esri has created it, let's take a look at what you have been doing in the industry. So we have a few customers over the past years that have shared their stories with IoT and with analytics in support of their business. All of these examples that I'm about to show you were stage presentations at the Petroleum User Conference over the years. This first one is an example that Marathon Oil presented, and they were enhancing their logistics and operations using IoT feeds and analysis on the backside. So what they did was they ingested a feed from their fleet. They used analytics to optimize the way that fleet was moving around. And you can read some of the quotes that are here from Lee Pena of Marathon, where they could save 20% on their operating costs by configuring and looking at this and taking this digital transformation on ahead. The next example was recently done by Apache. So Apache got on the stage of the Petroleum User Conference, and they presented on one of the digital transformation efforts that they were undertaking. In this case, they were ingesting a vehicle feed, and they were trying to solve and maximize the yield of how they conducted their operations. So there were several things that came in on this, and some of you have heard the term pump by exception, management by exception. So they wanted to ensure that they had a complete command and control view of their operations. These are SCADA feeds that are being input from the field and their assets. This is vehicle feeds and where their staff is in the field. And they want to make sure that they are sending the right people to the right asset to solve the problem at the right time. So there's a lot of things that go into this, but some very, very interesting results came of that. But in this case, they were able to implement or get this up and running pretty quickly. The final example is from OneOak. And OneOak was looking at ingesting sensor feeds, not only from their assets, but also live feeds for weather. So there's several factors that they were looking at. Primarily, they were looking at providing a competitive advantage and maximizing their return on investment for this. So you can read the quotes that are here, but they wanted to improve the health and safety of their operations and ensure that their product was placed at the right place at the right time to give them a competitive advantage in the market. So these are all examples, recent examples of customers that have shared their stories, their interests, and their initiatives in leveraging IoT and analytics. So this translates today to what you're all joining this webinar to see, which is the ArcGIS for Analytics for IoT. So on the next slide, I'll begin to transition over to why we have created this. So Suzanne is going to talk shortly, but ArcGIS Analytics for IoT is a combination, in my description, of several things that you may be familiar with. In all of the three examples I just highlighted, you saw customers that were using pieces of Esri technology. That could be the GeoEvent server, that could be the GeoAnalytics server. Well, what this new product is, it's a SaaS offering. Suzanne's going to explain it in detail, and Matt's going to demonstrate how this all works. But what this is kind of the best of all of those products merged together into a seamless SaaS offering. So you'll see how we can integrate real-time data, and we'll connect up and do some of that here shortly. We can, of course, build dashboards that help us monitor critical assets. We can do spatial analysis, which a lot of times is the harder step to do. You can ingest your feeds, but doing meaningful analysis rapidly and in a much easier to do way is something that has been a challenge. We can also do alerts, and then of course all of this is supported in the cloud, which has its unique benefits. So with that, Suzanne, I'd like to hand it over to you for you to introduce ArcGIS Analytics for IoT to the audience. Suzanne?
Thanks very much, Adam. So yes, as Adam was saying, Analytics for IoT is a new capability that extends Esri's geospatial cloud with real-time and big data functionality. Analytics for IoT provides a wide variety of capabilities for ingesting and working with observation and sensor data, which can be applied to different use cases. It's also an end-to-end system for analysis, so it supports analyzing sensor data in real time, in near real time with scheduling, and also over time. And then you can take immediate action as a result of your analysis, so sending notifications or even triggering downstream processes. As a product, Analytics for IoT is a SaaS, so one of the key differentiators here is its scalability and resiliency. Under the hood, it runs on a Kubernetes container-driven architecture, and this enables it to scale because compute can be distributed across parallel tasks, and to be more resilient because tasks that encounter issues can restart and pick up from where they left off. And it's fully managed by Esri, so this takes away the complexity of configuring and maintaining a suite of on-premise servers. Within the ArcGIS platform, Analytics for IoT is a new but key offering for real-time visualization and analytics. Many of you today may be familiar with the real-time and big data capabilities of ArcGIS Enterprise. So GeoEvent Server and GeoAnalytics Server are two of the primary products in Enterprise that allow you to bring in and analyze voluminous data streams. Analytics for IoT is the parallel to those products in the cloud. So it has GeoEvents capabilities for real-time incident detection and alerting, and GeoAnalytics capabilities for big data summarization and pattern analysis. And again, the key differences here, other than being a cloud-native service, are that speed and volume and the reduction in complexity and maintenance as a SaaS product. Analytics for IoT is designed as a flexible framework to support fundamental needs that we see across many industry use cases that benefit from IoT, sensor, and tracking data. And these needs generally fall into just three main areas that Adam already touched on in some ways. One of these is the need to ingest data being broadcast by sensors. The second is being able to process that data in real time to trigger alerts and actions. And then the third is the need to store and analyze massive amounts of historic data in order to reveal patterns over time that can provide insight for future decisions. The capabilities of Analytics for IoT are surfaced through different items in ArcGIS Online, if you're familiar with how content is managed in ArcGIS. And this includes a few new types of items that end users can configure. So this doesn't require advanced IT knowledge or administrator access. Feed items allow users to receive sensor inputs. Real-time analytic items allow you to perform real-time processing of those inputs, including triggering alerts and actions. And with big data analytic items, you could access and analyze big data repositories of stored observations. To bring data in, Analytics for IoT connects to industry standard IoT platforms, also to data lakes and to sensor vendor APIs. It does not necessarily connect to IoT sensors directly in most cases. And in this way, Analytics for IoT complements broad IoT platforms, bringing sensor data into ArcGIS for spatio-temporal reasoning. The feeds and analytics that you configure are managed by the new Analytics for IoT web application. Overall, Analytics for IoT is very much an engine. It's a hosted capability that runs real-time and big data jobs in the cloud. And the app is a full-fledged authoring environment for those capabilities, but without requiring any development or programming. And these new item types, the feeds and the analytics, they essentially represent those three common IoT challenges for ingestion, alerting, and analysis. And the way you can combine these together provides an extensive level of flexibility to tailor the application in this analytical engine to meet your needs. So what we'd like to do with our time today is really show you how this works in practice piece by piece. So first, Matt's going to walk you through how to easily bring in real-time tracking data with an example of fleet monitoring in and around well pad sites.
All right, thanks, Suzanne. ArcGIS Analytics for IoT is a capability of ArcGIS Online. Upon adding this to your ArcGIS Online subscription, you can quickly access the application from your app launcher on your homepage. This takes you to a simple-to-use web application where users can author feeds and analytics. You don't need to be an admin or an IT or GIS professional to use this application, and this capability can be enabled for anybody in your organization. One of the first things you'll often do with Analytics for IoT is configure a feed. Feeds are ways for you to consume real-time data sources to be visualized then on a map and to be used in analysis workflows. Before I configure my feed though, let's go look at a dashboard where I've already configured some common feeds that are used in the industry. Here, I've brought in SCADA data for alarms that are visualized as red dots on the map, as well as production metrics, which I've summarized to be monthly average daily production values. On my map, though, I can also see current vehicle locations being streamed into the map from our AVL solution. So combining all these different data sources and putting them into a similar type of operations dashboard can help to reduce transportation costs, improve worker safety, and then ultimately just make your operations more efficient. So let's look at how we can configure a feed for those vehicle tracks. When you create a feed, first you specify where your data is coming from. Your feed could be coming from ArcGIS. So this could be a feature layer that mobile users are collecting data into with mobile apps such as Survey123, Quick Capture, or Collector. And this might also be location tracking data coming from Tracker for ArcGIS, which is capturing workers' GPS locations from mobile devices in the field or in an indoor setting, such as an office or a refinery. You can also connect to different cloud IoT service providers, such as Azure, AWS IoT, or Cisco Kinetic EFM. And this really enables you to access any data that you're bringing into your big data streaming platforms. And then finally, we offer a highly flexible set of web and messaging options, such as subscribing to a WebSocket, a Kafka stream, and much more. To access my vehicle GPS locations, I'm going to connect to an Azure Event Hub where we're streaming the GPS data to from our AVL solution. First, I need to configure my connection with Azure by providing a name, an access key, an endpoint, and an entity path. Upon establishing my connection with Azure, Analytics for IoT will then connect and auto-discover the schema of the incoming data, and you can check the attributes, rename or remove fields, or change the data types as needed. In here, I can see I've got a timestamp field, which I can change the field type over to be a date. Then you have the ability to enable this data to be viewed on a map and to allow us to perform spatial and temporal analysis. And to do this, you just need to specify a couple of key fields. This includes the location information, which in this case are my latitude and longitude, as well as the spatial reference, which you can choose from a vast coordinate system library to match the incoming coordinate system of your data. You also specify the date and time that this record was captured. And then finally, you can provide a tracking ID, which is a unique ID associated to each vehicle or asset that's being monitored. So for vehicles, this could be the VIN number. With my feed fully configured, I can give it a name and a description. It'll take just a few seconds to initialize, and then I'll be able to view this data in the map. Analytics for IoT is spinning up these long-running jobs that are hosted for you entirely in the cloud. They continuously ingest data, parse it based off of how you've defined it, and enable it to be used in ArcGIS using those coordinates and time attributes. These feeds are visualized then as what are called stream layers. They display data immediately in your web maps and applications because they're continuously subscribed to the service which is pushing data. Now, once my feed is initialized, to view my data that I've configured, I can quickly add it to the new map from this item details page where I've got the open in map viewer button. This will take me directly to a map, and I can zoom in to look at my live vehicle locations updating. So just like that, we've got these vehicles moving on the map, and in this case, they're simulated to be a higher speed just for the sake of the demonstration. My map is live and dynamic, always showing the newest data. And users can look to this map to then understand where the workforce is, coordinate work in the field, and run their operations more smoothly and efficiently. At this point, I'm going to hand it back over to Suzanne to tell you more about feeds and how we can perform analysis on these to actually gain some business insights.
Thanks very much, Matt. All right. So what you just saw there is essentially the first step in leveraging IoT data, which is simply accessing sensor data and bringing it in. There's thousands of sensors on the market today, and being able to connect to that data and use it often involves vendor-specific data applications that are siloed, or it requires custom-built solutions to read in data, parse it, and integrate it with enterprise systems. Configuring feeds and analytics for IoT, as you saw, is an easy-to-use guided workflow. It lets you directly and seamlessly connect to external sources of observational data. So bringing data in from Internet of Things platforms, message brokers, third-party APIs, and so on. Feeds automatically derive the schema of the data, as you saw with the vehicles information that Matt was using, and they let you revise your data model on the fly. And then once they start up, you simply add them to a map to immediately see real-time information and combine it with other data. So this is both system integration and situational awareness configured in minutes and without writing any code. And bringing in data with feeds is really just the first step. So with real-time analysis, you can do more than visualize your sensor data. You can immediately put it to use. In Analytics for IoT, a feed is the input to a real-time analytic. And this can be used to transform, enrich, and detect incidents. Real-time analytics are a flexible model building capability that let you combine tools and take different kinds of output action. You can store sensor observations over time to a feature layer. You can send notifications and alerts, and you can even send commands and triggers to external systems to actuate behavior. So next, Matt is going to use that feed of the fleet vehicles and show how it can be used to put automated monitoring practices into place.
All right, thanks again, Suzanne. So to see real-time analytics in action, I'm going to look again at our vehicle locations feed that we configured earlier. Feeds provide real-time situational awareness for your operations, and there's a couple simple things that you can do to turn this map that we created a second ago into a valuable information product for any remote operations center. First, I brought in some contextual GIS data that already existed for operating areas, well pads, and field offices. I've also configured the symbology for my vehicles here to show both where vehicles have been, showing a historical trail of their locations, as well as where they're going by orienting these arrows in the direction of the bearing of that vehicle based off of an attribute we're pulling from the AVL system. And then finally, if I click on any of these vehicles, I can see who it is, quickly contact them by clicking on their phone number, and see as well what their job title is. So feeds make all of this possible, and a map like this can be useful for your operations teams. But the true value of analytics for IoT is in the analysis capabilities. I have this data that we've brought into ArcGIS, but what do we actually do with it now? How do we derive insights from the data and display that then in a map? So to go beyond just viewing these feeds like I just showed, this can be a really big challenge, especially when dealing with these large volumes and high velocity data, such as these vehicle tracks. So to make use of that data, what we can use is real-time analytics tools in ArcGIS Analytics for IoT. For example, if I wanted to know, using these well pads, which employees were at which facilities, I could simply use these well pads as geofences and, of course, visually see where when they enter these well pads. But with Analytics for IoT, you can use them as a geofence and automatically identify what facilities any given worker is at. Or what if I wanted to calculate when drivers deviated from their optimal driving directions? Here, I've added another layer to my map These white lines symbolize the optimal driving directions for each vehicle. I can click on it and see who's been assigned to each of these and see the vehicles following those paths. Now, optimizing your driving directions like these can achieve significant cost savings by reducing the total transportation costs and prioritizing the most critical work to maximize your production. And each route, again, has been assigned to a specific employee. But how do we understand the efficiency of a workflow like this and understand if there's an opportunity to modify the workflow to make it even more efficient? Especially, we want to know, are people following those prescribed routes? And if not, why? Ultimately, we want to make sure that these routes are being followed, and we'll use real-time analytics to do that. So I've gone back to the Analytics for IoT web application, and to create new real-time analytic, I'll select this button here, and it gives me the option then to either use a new feed or use an existing feed, which is where I would select that previously created vehicle GPS tracks. Now I'm going to jump over to a new tab where I've already started that. And like I mentioned, I want to bring in those optimized routes to do further analysis. So here on the left side, I've brought in those two data sources, one, the vehicle GPS tracks, and two, the optimized routes. In this model view that we're looking at right now, you have a simple to use graphic interface for configuring your analytic models. You can make use of these static data sources like well pads, areas of interest, or optimized routes in this case, and use them for geofencing, enrichment, or summarization workflows. And for analysis, at the top right, I've got a couple of different tool sets, such as ones for managing data, summarizing data, or using proximity, which I know in this case has the tool I need to calculate these route deviations. I'll wire up my two inputs into the calculate distance tool, and then I can start to specify my tool's parameters. The calculate distance tool finds the distance to the closest feature out of a set of candidate features, which are specified by this search radius. I'll make it 5 miles to encompass my operating areas. I'll also use this attribute relationship tool to make sure that I'm only comparing drivers against their assigned routes. We don't want to just compare people to any route that's nearby because that would result in an incorrect analysis. So I'll join together the route name with the name of the driver and then apply my configuration. After configuring the tool, I can preview what the output schema looks like. I can see we've got the route name or the driver's name, the coordinates, as well as the time. And then finally, I've also got this distance to feature. This distance to feature is what was the result of the calculate distance tool, and I can use that to find my deviations. Anything greater than 500 feet from the assigned route should be then captured as a route deviation. And so I'll use our filter by expressions tool, which comes with an out-of-the-box built-in arcade expressions evaluator. In here, I can pick from a number of different fields on the right side, such as this distance to feature field, and build my expression saying find all features that are greater than 500 feet from the optimized routes, and apply my analysis. So up until now, what I've done is I've brought in different data sources, and I've also tied up these two different analytical tools. The last step then is to configure an output. I want to use this data in a web map, so I'm going to output to an ArcGIS feature layer and tell Analytics for IoT how I want to update this data as well as retain the data for longer periods of time. And I'll give my output or my analytic here a name, which will save this as an item in my content, or this vehicle deviations layer as an item in my content. With my analytic fully configured, I can save it up here at the top right and then start it. Going over to a map now, with my real-time analytic fully configured, what's happening in the background is Analytics for IoT is creating another long-running job, which is also completely hosted in the cloud. These real-time analytics analyze each piece of data as it streams in, applying those processing steps that we defined to each and every event. This, in this case, would be the vehicle GPS tracks for every single vehicle. My white line indicates that optimized route, and I can see where this vehicle is exiting that route. As the vehicle exits the route, we'll be able to see historic or deviations occurring symbolized as red dots. So these red dots that appear on the map are some historical deviations. We can see all these different locations that appeared outside of 500 feet away from the optimized route. These observations are stored for future reference or further analysis if you need them in the future. We've seen how Analytics for IoT helps you to rapidly ingest live data with feeds, as well as real-time analytics help you to perform real-time geospatial analysis on those feeds, turning the data into information and business insights that then can drive return on investment. By leveraging completely cloud-hosted solution, some existing GIS data, as well as some simple configuration tools, you can build a valuable application for any operations group in a matter of minutes in this case. And the time to value has been reduced enormously. So with that, I'd like to hand it back over to Suzanne to talk about where we can take these large amounts of data that we're acquiring.
Thanks very much, Matt. All right. So real-time analytics that Matt just showed provide processing horsepower to your IoT sensor workflows. Instead of requiring custom-built applications that need to incorporate complex streaming analytic code bases, really any end user can assemble an end-to-end workflow to detect incidents and capture data. Real-time analytics process each message from a feed continuously as they arrive, and they can leverage static data sources also to serve as geofences or enrichment data, which is what Matt was doing with the optimized routes. You can combine different tools together into a workflow, step by step, to ask any number of questions, and then you can associate different output behavior with each one. So in some cases, you might store data, as Matt was showing, with the deviations to the optimized routes. But in other cases, you might send alerts or send a command to a third-party system. Overall, real-time analytics are useful when your decision timeline is operational, when you need to know about something and take action immediately. So overall, there's extensive support for different real-time and big data systems and various data formats in Analytics for IoT. And these are aimed at covering major commercial IoT platforms, as well as common real-time messaging technology. For example, MQTT can be used as a bridge to bring in vehicle tracking data from vendors like Geotab. An Azure or AWS IoT Hub can be leveraged to access data from a SCADA system and make it available externally. And we're also planning to build cloud-native integrations for common used systems like OSIsoft Pi. We'd be very interested in working with an organization that uses OSIsoft in the cloud. Beyond real-time visualization and analysis, you can also work with information you store over time. So far, what you've seen is Matt using a feed to bring in and visualize real-time data. These, of course, get used in the real-time analytics for immediate awareness of incidents. And real-time analytics can store observations over time to a feature layer. As data arrives in real time, however, these historical data sets, it can grow to large volumes extremely quickly, especially if you're storing all tracks from moving types of sensors like vehicles or personnel. Even just 250 messages a second can grow to 20 million records within one day. And for that reason, Analytics for IoT is designed to grow with you. It includes fully configurable big data analytics so that you can process this information for trends. These big data analytics can be traditional ad hoc analysis, but they can also be scheduled and run in near real time to support different workflows. So there's a lot of extra capability here. And what Matt's going to do next is walk you through a few examples of big data analysis, both in terms of this scheduled processing as well as ad hoc traditional pattern analysis.
All right, so to understand big data analytics in Analytics for IoT, first we're going to look at how you can perform, again, like Suzanne mentioned, near real-time analysis by scheduling analytics. And in this example, we'll utilize some weather observation data to understand the health and safety impact against our workers as well as our operations. So at any point in time, weather events might be having a potentially impactful they might be potentially impacting your operations. For example, a tornado warning or a heat advisory might be impacting the health and safety of your employees. I can zoom into the map and quickly see these heat advisories out in West Texas. Or a forecasted winter storm might be resulting in a demand spike for natural gas. How do you anticipate and prepare for this demand as a pipeline operator? And again, for those of you operating pipelines, flooding events might be increasing the risk of channel erosion along your pipelines. Here, as I zoom in, I've marked on my map with these blue and white dots every location where you have a stream or river crossing with our pipelines. We can use weather data to understand the risk of channel erosion and mitigate it by inspecting those stream and river crossings as events occur. So let's go back to Analytics for IoT and see how we can run this type of an analysis. Again, you use the same type of a model building experience as we saw with the real-time analytics. And in this case, what I've done is first, I've brought in stream crossings and flood warnings coming from Esri's Living Atlas. And we're joining those two data sets together to enrich any flood warning that occurs, any of those data sources, where they are, what type of event, when it's happening, enrich that data onto those stream crossings that we just saw a second ago. When I go back to the map, and on this flood warning, we can see one of those happening. So here's a flooding event on the Brazos River, and visually we can see how it intersects with, in this case, one of our stream and river crossings. But with Analytics for IoT, instead of doing that visually, we can detect these types of intersections automatically. Now, on top of that, I also want to notify the manager for this operating area that this is happening. So again, I zoomed out a little bit and I can see this this box outlining an operating area, and we've specified who the manager is as well as their email so that we can send them notifications. Back in the Analytics for IoT model, I've brought in those operating areas and again joined those features from the previous output to the operational areas, enriching the data with now the manager's name and email. Finally, I need to output this data. First, I can output to a feature layer so that I can then view this and alert people in something like a dashboard or a map that we were just looking at. And second, I can also summarize all of the attributes and send them emails to people using what we just got from those operational areas. Now, to put this into actual operation, you can choose to either run this once up here or choose to run it at reoccurring times. For example, if I choose the recurring time option, I could run this every night at midnight, or you can schedule the analytic to run on regular intervals, such as every 15 minutes, which is what I'll do because I know that's the frequency with which the weather watches and warnings layer is updating. I'll save my configuration and start it. And in the background, that's going to get spun up, and I should receive an email telling me, in this case, a flooding event has occurred in your pipeline operating area, increasing the channel erosion risk at a stream or river crossing. So I can view this information and location in a map, and it provides me a link to go view that. When I open this map, it automatically zooms me to the location where this is happening, and I'll see a red dot indicating a location where you've got a stream or river crossing with an increased risk of channel erosion. So with just a handful of steps in leveraging data that's coming from Esri's Living Atlas, you can implement workflows like these to help improve the health and safety of your workers as well as your assets. Now, with that example you saw though, these tools weren't used necessarily for big data, but they're more so used for reoccurring analytics that you can use to achieve near real-time analysis through that scheduling capability. But I want to go look at one more example where we're actually handling much larger data sets. If you take, for example, those vehicle feeds that we established in the beginning section, with just 100 trucks in a fleet capturing GPS tracks every few seconds, you can easily start to generate nearly 1 million records every single day. And Analytics for IoT provides a way for you to quickly visualize this data by dynamically aggregating the data into summary bins that update on the fly. As I zoom in, I'll see these summary bins updating, showing me the total number of records that fall within those areas. With all this GPS data, you might be interested in understanding information like vehicle utilization rates and whether there's a need to reduce or increase the size of your fleet, which I've marked up here at the top right or top left. We've also calculated statistics like how many miles are being driven every day by specific employees and over time as well. With this information, you can look at opportunities to save money by reducing driving costs and windshield time, and then track how those metrics are changing over time to prove the value of different changes that you might be making in your operations. To calculate these mileages, I could use out-of-the-box reconstruct track tools that come with analytics for IoT. You could also use the same data, though, to determine when facilities were visited last. As I zoom in, I can really start to see how these bins follow the roads, and I can see the well pads that they intersect with. As I jump over to another map, though, I've started to symbolize my well pads based off of their last visit date. Red indicating well pads that haven't been visited in 2 weeks or more. So to create an analytic like this, I'm going to jump over to another analytic that we've configured, and we'll look at this at a really high level. First, I've brought in historical GPS data, well pads, as well as operating areas. At the top, I'm aggregating the historical GPS data into the well pads and outputting to a feature layer that's storing these daily site visit logs. That's what's driving the map that shows those well pads colored based off of their last visit date. And then at the bottom right, I'm also choosing to summarize all this data based off of different operating areas to calculate the visit rates for each region. And we can use that to compare it against our goal of visiting 90% of facilities. Now, if I jump back to my dashboard and zoom out a little bit, we can start to see what that looks like. I've got 3 operating areas here. And as I click them, I see this chart down here in the bottom left updating me, showing me the visit rates, meaning the total number of sites that are visited every week by the operating area. And we can compare that again against our goal of 90% highlighted here in this chart. We can see areas that are declining, staying steady, or in this case, increasing, and compare them against the goals. So all of this is really designed to help you make sure that your sites are not going too long without being visited and ensure that they're environmentally safe and operating efficiently. And these are just a handful of examples of how you can use analytics for IoT to turn big data and real-time data into business insights. We brought in SCADA, weather, location tracking data, and answered questions that ultimately help you operate more safely and efficiently. And we did it all with a big data infrastructure completely in the cloud that enables you to run analysis on millions and millions of records. I'd like to hand it back over to Suzanne to recap on some of the things that we saw today.
Thanks very much. So big data analytics can be used to analyze data that you store over time in analytics for IoT, and that's helpful because data that comes in real time can become more and more unwieldy to work with as it grows. So these analytics can help reduce the need to configure and maintain on-premise data centers and keep them optimized because they run in the cloud and there's no need to configure big data architecture on-premise. With big data analytics, you can run analysis either on feature layers with data that you've stored over time, or you can reach out directly to cloud big data stores like Amazon S3 or Azure Blob and work with data that's being fed by other organizational systems. Much like with the real-time analytics, you can stitch together different tools in an overall automated process and create multiple information products at the same time on the same data. And furthermore, the same outputs are available in big data analytics, so you can take automated action in your IoT system based on overall system status. Big data analytics are useful when your decisions are tactical, when you need to make a decision regularly based on standard practices. For that, you would use scheduling. And they're also, of course, useful when your decision timelines are strategic, when you need to learn over time and adjust larger approaches. Now, there's a wide variety of spatiotemporal analysis tools included in analytics for IoT. This includes tools for summarizing data, detecting different kinds of incidents and behavior, analyzing patterns, and leveraging proximity in various ways. These are largely the same tools that are available through GeoAnalytics Server today. This also includes tools and concepts from GeoEvent Server, which focus on tracking and movement analysis. So things like calculating motion statistics, summarizing journey and trip information, and snapping tracks to a road network. All of these tools can be used in big data analytics, and those that can operate on a single message at a time also work in real-time analytics. So things like calculating a field, mapping fields between one schema and another, creating buffers, and so on. With that, we'll go ahead and wrap up our overview for you today. Analytics for IoT makes real-time and big data capabilities available as a service in Esri's geospatial cloud, and allows you to ingest sensor data with feeds, but also to put that data to work for you with analytics that transform, enrich, and assess patterns, taking action along the way. What this provides is a flexible and extensive framework that can be configured to support a huge number of use cases and that drive various business improvements. As you saw, these feeds and analytics can be combined to support fleet tracking and route deviation, which improve worker and asset safety, mileage, activity analysis, and worksite assessments to reduce operational costs and increase production efficiency, and enhanced awareness of environmental risk. And this is just a small sample of how these capabilities can be leveraged. These capabilities are very similar to what's possible with our on-premise real-time and big data technology, but there's some key differences here that I'd like to emphasize. First, Analytics for IoT has been designed from the ground up to be much easier to use with guided, configurable user experiences that enable analysts and end users to simply connect to real-time and big data sources and leverage them in analysis. No custom developments required, which cuts out both time and cost in getting efficiency-oriented workflows into production. It's a cloud-hosted SaaS, which reduces procurement and maintenance expenses for on-premise infrastructure. And it's managed for customers by Esri. And this is really huge. Organizations today can spend hundreds of thousands of dollars or more on staff and projects that are configuring, optimizing, and maintaining in-house real-time and big data architectures. Analytics for IoT is run by a dedicated operations team that handles this for you. So abstracting all that complexity so that you can immediately just start working with your sensor and observational data. And lastly, but possibly most importantly, is scale. Analytics for IoT is built on container architecture. That means feeds and analytics can be scaled for high velocity and high volume workflows. Feeds can be scaled to tens of thousands of events per second and higher, and analytic jobs can accommodate historical data analysis on the order of billions of features. So this is a cloud-native, scalable, and directly configurable analysis engine. Thanks very much to everybody for joining today. We hope this has been a helpful overview. If you'd like to find out more, don't hesitate to get in touch with your Esri account manager. Adam Pittman can always guide you guys to who that is if you're not immediately familiar. And we also just wanted to leave you guys with the note that the Esri User Conference is coming up in a few weeks. And as some of you may be aware, this has transitioned into a virtual event this year. We'll have a variety of real-time GIS presentations in that conference, and also a virtual expo dedicated to Analytics for IoT if you'd like to connect with the product team and find out more. Adam, did you want to add anything else as we wrap up here and take questions?
Yeah, we've got a lot of questions coming in right now, Suzanne. But I mean, we're excited that this product is released. I think Suzanne would tell you a lot of stories about how over the years we've listened to customers and tried to figure out what their needs are and how to better support them. And we believe this is a really great tool that you can get up and running with quickly. I mean, everyone saw Matt. Matt was working in real time, configuring those feeds and using the product, and that's the experience that you would expect to see as well. So we're excited to hear from you. We're excited to work with you in support of any projects or initiatives that you have where you feel this could be beneficial. All right, well, we are at the top of the hour, Matt and Suzanne. Are there any parting comments that either of you have before we wrap it up?
I think I would just say thanks again to everybody for joining, and we've been very much looking forward to getting this capability out there and exposed to different organizations. So we hope that this was helpful, and we're looking forward to talking with you further.
I ditto that. And if you have members of your organization that would benefit from this recording, this topic, you're welcome to share it with them. And we thank you all for taking time from your day to learn about ArcGIS Analytics for IoT, and we wish you the best. Thank you very much.